Hey everyone, welcome back for episode 21 of the Zephyr Tech Talks. Kind of a special one today because we will be talking about all things Zephyr 4.0, the new Zephyr release that just came out, I guess, last Friday, just a few days ago. And we will be having people from all over the world watching us, like always. So please feel free to say hi in the comments, whether you're watching from LinkedIn or YouTube. But we will also get people from all over the world as guests, because as always, what I've done is I've invited some of the contributors, maintainers, release managers also who've helped craft and contribute to Zephyr 4.0. Really just a few out of the 600 plus people who contributed. But yeah, like gathering people from Denmark already, people from other places. So yeah, please say hi, whether you're joining from YouTube. By the way, if you're not subscribed, please do. People from Brazil, always nice to see familiar faces. People are joining. It's been only a week, right, since we did the last episode. Let's see. So yeah, we're going to talk about all things Zephyr 4.0. I hope you brought questions, like depending on whichever area you're most interested in Zephyr. You probably, you might have some questions. So this will be a good opportunity to ask all our guests, which I will be bringing on screen right now, and we will do a quick round of intros. Some for familiar faces, some new faces. So yeah, let's see. We have Tommy. Tommy, who are you? Where are you joining us from, and what was your role in? What in general is your role in Zephyr and for 4.0 in particular?
Yes, so joining from Finland. Yeah, I'm Tommy, working at Nordic Semi for a few years now. And I've been working with Zephyr for about a year and a half. And I've been contributing to it for almost a year now. I started with cellular modem stuff, but then nowadays I'm working with security, so different topics under that, one of which is secure stretch, which we'll be talking about more.
Right, and for those who watched the Zephyr 4.0 release highlights video, where I tried to, and I hope I did a good overview of what's new in Zephyr 4.0. I kind of made a joke that I probably did some mistakes in the way I covered things like secure storage, which is your part, and that I will have people to correct me today on Wednesday. So this is going to be your role today. Tell me what, tell us all about secure storage and the truth about secure storage. All right. Next we have Riyadh.
Hello everyone. So my name is Riyadh. I work at Bay Libre. I'm joining from France. And regarding Zephyr, I was lately working on different topics, and especially the latest topic is ZMS, which is the new storage systems that is part of the release 4.0. So we're going to talk about this later.
Yeah, cool. Perfect. Robert.
Yeah.
Hello, my name is Robert. I am working at Nordic Semiconductor located in Krakow, Poland. And as for Zephyr, together with Yuka, we are maintaining the networking subsystem.
Great. Fibang.
Hello, I'm Fibang, joining from France. I work for NXP for about 3 years, and I work mainly on multimedia camera, video graphics. And I've been with Zephyr for about a year, I guess, and I'm a collaborator of the video subsystem.
Great. Yeah, looking forward to hear more about video later today. Cool. Mahesh.
Hello, everyone. My name is Mahesh Mahadevan. I'm joining from Austin, Texas. I work for NXP Semiconductors, and I've been with the Zephyr project for about 4 years now. And I was one of the release managers, along with Dan, for the recent Zephyr 4.0 release that went out last weekend. Thank you.
All right. Next, we have Anas, who's been with the project for just a couple of months, right?
Yeah. Hey, Anas here from Montreal, Canada. As Benjamin noted, been a while with the project and involved in everything related to releases, features, everything. Yeah, so that's why I'm here.
Yeah, cool. Yeah, like we always do, I think, and I hope we can do that today as well. It's all about like learning more about 4.0, celebrating it to some extent, but also discussing what's next, right? And so if you're watching us, anything we don't cover explicitly doesn't mean that you cannot ask questions and bring into the table so that we can discuss. If there's anything you would like to see come to Zephyr, we can certainly talk about it. We can also share some pointers as to how it works when it comes to getting new features, sort of like fed into the GitHub backlog and whatnot. So yeah, and last but not least, Dan.
Yeah, hi. I'm Dan Kalowski. I'm out of Portland, Oregon. I was one of the release managers, so I guess I also work for Ampere Computing. So yeah, I worked with Mahesh quite a lot on getting that release out.
Yeah, kudos for getting it off the door right on time. It's actually quite nice that every 4 months or so, the release comes out at a very predictable date, which is, I think, which downstream users, I think, appreciate. So, yeah, like I said, we will be going through some of the news. Let me just share my screen right now. Where is it? It's here. Yeah, so the release notes, there's like, I think literally thousands of entries in there, or thousands of lines at least, of things that were one way or the other are noteworthy in terms of new features, bug fixes, API being changed, being introduced, etc. But we called out a few changes that are more noteworthy, I guess, than the others, and this is what we're going to cover today. If there's anything else, again, that you as viewers care about, just chime in the comments, and we can certainly talk more. Yeah, too. I mean, a couple of like significant chunks of this release are secure storage as well as ZMS. Turns out, I guess this will be the ones that we'll be covering in this particular order. So, yes, secure storage is all about what, Tommy? Actually, you tell us, so that I don't say any more wrong stuff than I did already, maybe in the video, like I said. So let me just make sure that we have you here, and you can tell us a bit more about what made it into 4.0, maybe some of the stuff that couldn't make it and that is still like ongoing development. That'd be great.
Sure. So let's start with an introduction of what it is, like the reason why and so on. Do you have maybe the release notes as a support?
Sure, I can put them on screen again. Sure.
So for now, yeah, basically the secure storage subsystem implements the PSA secure storage API, which is it's specified by the PSA certified. I don't know if we can call this an organization, but it's an external specification.
Consortium?
Maybe. And it's a simple set of functions, basically set, get, remove style functions. But there's like the spec is long because it covers quite a bit of ground. And well, first thing I can say is, well, I'll say this a bit later to try to tell things in order to not confuse everyone, because this easily gets confusing when you don't work with this. So as a bit of background, Zephyr is moving to the PSA Crypto API as the one standard API to use for everything crypto. And so it's a different API than secure storage, but the PSA Crypto API makes use of the PSA secure storage API for storing keys to non-volatile memory. So when using persistent keys, the keys are stored through the PSA secure storage API. So this is what the subsystem provides. in part. The second part is that it also allows the application or any code really to store any asset. So yeah, those are the two big use cases. And by making the PSA Secure Storage API available on all the board targets, as is written in the release notes, it allows to make use of the persistent keys in the PSA Crypto API and in a standard way. So we standardize both on the PSA Crypto API for crypto operations and now on the PSA Secure Storage API for storing assets in a secure way, or at least it's not. Yeah, big disclaimer is that it's not guaranteed that the data you store through this API is going to be secure when you use the secure storage subsystem, because as I was saying before, the first goal, the primary goal, was to provide functional support for the API so that we can standardize on that API and it's usable on all the board targets. And so it's actually going to be device dependent, device specific on like whether you get any security or not, and like what level of security you get. Because
so what are some examples, or like what does it take to actually get reasonable or good actual security then?
So right now, with the current implementation we have for the Zero, it requires you to provide a function that provides a secure encryption key. And you also need a random entropy source. So just a good entropy source, like not a test entropy source, not test RNG. And yeah, it's really about the encryption key right now. So right now it's something that could be part of future work as to sort of define an API in Zephyr, like a sort of driver interface to as a way for different devices and platforms to provide encryption keys in a more standard way, because right now we don't have this. And so the security relies on obviously having a secure encryption key.
Okay.
So this standardization also allows to use this API, because this API was already implemented by TFM, which might not be familiar to a lot of people, and I don't think we'll have the time to really go into detail here. But it's a software solution that provides isolation and good security on devices that support it. And it already implemented this API. So now it means that we can make use of that API on all the board targets. So on any code, basically, not only on code that only runs on those platforms that have TFM. So standardization really helps the adoption of also the PSA Crypto API. So yeah, first goal was the functional support. Then we have device-specific protection. And the subsystem is not fully compliant with the specification because the first goal was to really enable all the platforms to support the API, at least at the functional level. So there are it's listed in the documentation. Maybe now if you could click to go towards the documentation of the subsystem. So there's a part about limitations and ways that the implementation purposefully deviates from the specification and an explanation why. So you can have a look at this for more information. Also, one of the big limitations right now. So to say a few words about the specification, the PSA Secure Storage API, it actually defines two APIs. We have the internal trusted storage, which is what the PSA Crypto API calls for persistent keys. And it's like typically we have one is referred to as being stored in an internal flash and the other in external flash. But right now in Zephyr, we only really have an implementation for the ITS, which is the internal flash. The API for the external flash, called the protected storage, PS, is also supported, but it directly calls, as of now, into the ITS, which is the internal flash API. So what this means in practice is that right now we don't have support for storing secure assets, storing assets through the PSA Secure Storage API to external flash, unless you put your storage partition on an external flash, but then you'll have absolutely everything on external flash. So in the future, possibly, this is something I would really like to work on, but just haven't had the opportunity to so far, to add like proper support for storing on external flash. And I know there are interested parties already, and this would be a good thing to have. But we have the internal flash storage.
Okay.
Also, currently there's a PR up that adds. So it's made in the subsystem is implemented in a modular way. So we have a sort of backend for storing the assets, like writing and retrieving to and from non-volatile memory. And right now, the only backend we have for 4.0 is uses the settings subsystem for storing and retrieving. And one thing I've submitted, which is in a PR right now, is adding a ZMS as a backend, an alternative backend for storing the assets, for writing and retrieving. So it will have the advantage of being more efficient in different ways, and also to give more control over the partition that is dedicated to secure storage. There's another topic also that I think will need to be tackled next. Is about the use of UIDs. So all the entries we get and set through the PSA Secure Storage API, they are referred to with numerical IDs, UIDs, they're called 64-bit UIDs. But the problem is that we don't really have namespacing. So there's the risk of UID collision when we have different users that are not necessarily aware of each other. For example, you'd have, let's say, the Bluetooth subsystem, and then you have an application or another subsystem. If they end up using the same UIDs, then you'll end up in trouble because you overwrite each other's assets and so on if you don't have like separation. So there will be something done, some work about this too. Most likely done in such a way that different ID ranges are assigned in a static way to different users. So yeah, this will come up for 4.1, I'm pretty sure.
Okay, cool.
I think that's about it. Yeah, there are two samples. One of them Benjamin played with in the release video. There's another one. Unfortunately, it is actually listed here. Yes, this one shows how to use persistent keys in the PSA crypto API. And so this is now made possible with the secure storage subsystem for platforms that don't use TFM. So yeah, the two samples, documentation, there are also tests for it. So I just encourage you to start looking into it, using it, giving feedback or asking questions. I'm active on Discord, so in the security channel, this would be appropriate, but yeah.
Great, perfect. Yeah, so I don't see any questions in the chat just yet, but yeah, that was pretty clear actually. Thanks for that, and thanks also for the transition, I guess, and segue into ZMS, because we can certainly talk about that too. I was wondering myself, well, like when I did the demo, I was like, oh, okay, yeah, settings as a backend is nice, but it felt sort of natural that this would be coming. I didn't know about the PR, but it's great to hear that ZMS is sort of next. So yeah, Riyad, why don't you tell us a bit about what ZMS is? And like we were briefly discussing before going live, I think people, including myself, have questions regarding like what that means, or like how is that different from existing file systems that we might have had, or we still have, like LittleFS, when one should choose one or the other, what are the differences? And like Tommy did, maybe also we can briefly talk about anything coming next, if that's the case, if you're already planning on doing more in 4.1.
Yeah, thank you for the introduction. So let's start with I mean, how it started. ZMS, it started first when there's the need with some new technologies, like for example the RRAM and RRAM. So these new technologies, they're not like the traditional flash. So for people that don't know traditional flash, they need to be erased before being written again. But these new technologies, they do not require an erase in order to do a write. So that's how it started. Currently, the storage systems in Zephyr, they do not work correctly with these new technologies. And to answer your questions about what's the differences between ZMS and the other existing file systems. So first of all, I want to clarify that this is a storage subsystem. It's not I don't want to call it a file system. People sometimes confuse between both of them. File systems has a lot of overhead. It's dealing about files, and so it has a huge overhead compared to the storage systems, like for example ZMS, and also there is NVS, which is
Yes.
also a lightweight storage system. So ZMS is part of the lightweight, let's say, family of storage subsystems, and it's a key, what we call a key values storage subsystems, which means it's dealing with storing pairs of keys and data. So that's the main difference between ZMS and, for example, little FS, which is dealing with files. So what's new with ZMS? Like I said at the beginning, the first thing that it supports and it's optimized for these new technologies like NRAM and MRAM, and also it supports all the other traditional NOR flashes. So it will cover all the type of technologies.
I actually a quick question there. I
Mhm.
didn't dig deep enough to find an answer to that. Like, how how are the sort of optimizations handled? Like, does one need to like enable specific configuration
Mhm.
flags if they
Mhm.
know their flash has such or such characteristics, or is this just like magically handled by a device tree and whatnot?
Yeah. So ZMS, I made it to be as simple as possible for users and to be as to transition, for example, from current stories like NVS as simple as possible, because all the magic is done internally in ZMS. And user do not have to care about what's going, how the write is done, or how the erase is done. Um, so maybe if you want to, I can explain how it's working internally. Internally, basically, the main differences between the current storage system, which is, for example, NVS is relying on a state of the memory to do its operation correctly, which is optimized for the the traditional flash. It's relying on, for example, the arrays value to do its operation correctly. ZMS, on the other hand, is not relying on this, and it's relying on another mechanism called the cycle counter that will be used to validate or invalidate data within the sector. So all of this, the magic, let's say, is done internally, and the user API is almost similar to what was previously, for example, with NVS. Or um, so, like I said, one of the main feature is that it supports these two technologies, and while keeping, let's say, the wear leveling feature, which is the most important feature for this kind of devices. That, some of them, they don't have a very long life expectancy, so any additional writes could harm the device, and that's what is why ZMS is needed for this type of devices. Um, One additional things also we added to ZMS compared to the current storages is that it has a bigger, it can support larger sector size and partition size. Also for storing, like I said, it's a key value, so it's like storing a key with the data. Now we support 32-bit IDs, 32-bit width keys to store the data. So it's a large, let's say, amount of IDs that could be stored. And also, one additional features that we added is to make reads and writes faster. Is now that for usages where you store a small amount of data, which are less than 8 bytes, all of these data are stored in the header itself. So you only need one read or one write to store them or to read them, so it's faster. So these are the main, let's say, features of this new storage subsystem. And yeah, like you're showing here in the documentation, and like I said, this is the version number 1, so it's gonna evolve a lot from this first version, and many other features I listed in the documentations, some of them that I'm working on them and will be found on later versions of Zephyr. And for example, one of the features is going to be that we can adapt multiple we can put multiple formats of the header, which is called ATE in ZMS in the future versions. One also possibility, I think it's listed here. Yeah, it's in the 4th point. Yeah, which is also important, is that today we don't have an idea how the memory is, what is, let's say, the state of the memory, if it is used or not, what is the wear out of the memory. And using the cycle counter, like I said previously, that's what I use to validate or invalidate data. We can actually add a feature where we can get how much our memory has been written, and so we can in advance know if the memory is about to die or not. So that is also one of the important features I'm gonna add. I also have I'm working also on the backend for settings. So I know a lot of users, they use the storage subsystems on using the settings subsystems. So one coming feature will be to add the backend of ZMS for settings.
Okay, cool. There's actually a question. You kind of covered it. Like in ZMS, how does and how will the storage partition work?
How will the storage partition work? What do you mean? I mean, can he
Yeah,
clarify
that
maybe the question?
I was going to ask Yovel to probably elaborate on the question, because maybe kind of related, or maybe that's what's behind the question. To your point about NVS or ZMS not being file systems per se, like could they be sort of the underlying backend for something like a proper FATFS or LitterFS file system?
Yeah, actually, these storage subsystems, they could be used directly. I mean, people can like use ZMS read and write, and it will read
it's
from
not files, as in like you don't have paths and
yes,
stuff, but still
exactly,
you have key values.
exactly. Or it can be used from settings, and settings actually is using kind of a path value to store data. So yeah, it can be used in both ways. And maybe, I mean, I don't know if we can go into details about how, I mean, to use these storage systems effectively, the most important part is really to dimension the partition, to dimension depending on the number of data that is used or is going to be used in this partition. And also, like NVS, there is the number of sectors and the size of sectors. All of these parameters needs to be really well dimensioned to reach an effective use. And all of this is described in the documentation. I've tried to explain all the, let's say, the normal cases where people are gonna use some amount of data, and I try to explain how to dimension the number of sectors and the sector size and so on. Because ZMS also needs, let's say, some overhead and some sectors, one reserved sector, for example, for it to be functional. So all of these parameters needs to be taken into account when dimensioning a partition to work effectively with ZMS. And everything is explained there. And I'm happy to answer any question or help anyone that wants to add the support of ZMS for any usage.
Right. Let's take one quick additional question from Tyler. Biggest advantages of using this over LittleFS?
Like I said, LittleFS comes with a bigger
footprint, I guess you're
footprint.
saying, right?
Yeah, it is very. Yeah. And it's because it's dealing with files, it's dealing with dynamic blocks. It will change the blocks. It will detect also if a block is damaged and so on. So it comes with a big footprint and a big overhead. So it's also slower. So these are lightweight, let's say, storage system. I don't want to call them file system. Storage system, lightweight storage system.
Yeah, no, that's a great way to answer it, Tyler. I hope this answers the question. Great. And like I called out in the video, and you mentioned it again, the documentation. Yeah, you did a really great job at explaining, the background behind the mess, and like I'm showing on the screen, and that you were just covering tips and tricks to tweak block sizes, etc., to get to make the best compromises, basically, in terms of wear versus performance, etc. So, yeah, kudos for that. I wouldn't be surprised if more questions come in the chat. If there are, please, people, line them up. We can answer them later. Moving back to the release notes, there were a few. Actually, I think we have one new guest that just joined us backstage. Gile, I see you backstage. I will put you on the screen if you're ready to tell us a bit briefly about stepper motors. Otherwise, we can start going through this one. Basically, I skipped a few bullet points there, but as always, there's and I'm going to put myself on the screen so that you can just relax. Whoops. There we go. Yeah, lots of multitasking, getting there eventually. Driver classes, like a few new classes of drivers for analog comparators, stepper motors, all things aptics drivers. So basically new APIs alongside a new set of actual driver implementations for these specific IP blocks. Just check it out. Like a bit is covered in the demo video as well. And one thing that I was really exciting to see, and like I mentioned also in that video and that blog post, Zephyr has been enabling audio and video use cases for quite a while. But to some extent, at least that's my personal opinion, video specifically, this was still pretty rough around the edges. But over the past couple of months, a lot has happened. So I will be bringing Fibang on stage to talk a bit about what's happened, what are some of like the main changes, some pointers maybe for people to get started, and like we did for the couple previous topics, maybe also if you have already some thoughts, insights as to what might be coming next, we can talk about that too.
Yes, sure. So for video, we have more and more new platforms coming with camera features in this release. And we had to make some notable changes in the video API to support the new requirements coming from these platforms. For example, from SD, we have the Arduino Nicola Visions coming with the DCMI DVB camera interface and the Galaxy Core 2145 camera sensor drivers. And from Espressif, we have ESP 32 S3 board coming with the LCD cam DVB interfaces drivers. And from NSD, we added the OmniVision 7670 camera sensor drivers and a smart DMA drivers coming with the MCX and 947 board. And due to extra constraints on this IP, the smart DMA driver has to divide the camera's frame into multiple Baxion video buffers. And we have to extend the video API to enable this Baxion frame streaming. Also, in terms of video API changes, we also introduce more options for users to choose between a normal heap and a shared multi-heap when allocating video buffers. The shared multi-heap is a pool of memory regions with extra capabilities such as cacheable, non-cacheable, or even external memory, which can be added at runtimes. We also added an API to control the camera frame rate. We already had the set and get control APIs to change some camera sensor properties like contrast, brightness, saturations. But the frame rate is something more than that. It requires some modifications in several devices in the pipelines. It also depends on the format and the resolutions. That's why we need a dedicated API for it. And the camera pipeline on the NSB RT1170 is the first one using this new API. And what's more, we also added a new video capture samples, which is similar to the classic one, but instead of using the display API directly to display the video frames, it's one's passed by the LVGLs. So I think with these samples, it will be easier to display more things on the screens. For example, we can add some GUI overlays onto the video image. About the camera testing, before the 4.0 release, we just have build-only test, but now we added an automatic test to capture samples, which can check if the camera image can be dumped onto the memory, and even if the image is correct or not by using the test button generated from the camera sensors. So this will be helpful to detect some regressions in the camera pipeline, I think. And last but not least, we introduced a new video interface bindings. Like many other bindings, it allows to unify some common properties for data exchange between video devices. But there's something more about it that I want to highlight. Can I share my screen?
Yes, please. Yeah. Yeah. While you're showing your screen, maybe I will be just putting I was mentioning the Zephyr 4.0 release video. So like check that one out. Among other things, one thing that's being it was loud. One thing that's mentioned there is the or demoed there is the video subsystem in action. Running on an ESP32, really tiny camera and round display. And like I was saying just before, like a few months back, I don't think it would have been possible to run, like to really have like just a working demo of basically a webcam running Zephyr with like it just works. Like the code sample just works. Frame rate is really, really good. So that was pretty cool to see. And with that, I can put you on the screen. Or maybe I'm too early. Tell me whenever you're ready.
Sorry, I don't. Do you see my my PDF?
You're actually. I think you're sharing your
email.
Not sure that. Yeah, like you're sharing Outlook. It doesn't sound right. So I hope there wasn't any confidential emails there.
Share slide.
Or you will be in trouble. So yeah, Zephyr 4.0 highlights video. Make sure, like if you're watching us on YouTube, it might actually already be showing up for you on the side. Watch it, share it, subscribe to the channel. It's been pretty popular. Like people have been watching it quite a lot over the past few days. Always interested in getting feedback about things that maybe we should have covered and forgot to cover. I'm always also interested in getting cool demos to feature there. So for 4.1, feel free to reach out. Should I put you on screen? Like,
I think it's okay now.
Okay.
Yeah.
Right. Sounds good.
Yeah.
Chicken and egg issue.
So this is for typical camera pipelines. We will have at least two devices. For example, receivers and the sensors, and the receiver will need to reference to the sensor device. And a command button to do this is to use the p handle reference directly like this. But for some camera pipeline hardware, we will have a conference like that. The receiver need to be initialized before the sensor to give clock to the sensors. But by using the reference by handle like this, the sensor need to be initialized before the receiver to be able to compile. So we will go into some sort of chicken and egg issues in the init orders. So with the new video interface bindings, we replace this this p handle reference by the string reference with the endpoints and remote endpoint labels. So the remote endpoint labels is just strings that give that point to the remote device. So with this, we can retrieve the remote device object later by using just the DT string token macros, and we can avoid the chicken and egg issues.
I see. Yeah, makes sense. Okay.
Yeah.
So yeah, briefly, when it comes to next release and beyond, like what are some of the improvements people can expect around the video subsystem? I guess maybe like more video pipeline sort of stuff to process like video data even further.
Yeah. For the next release, I think we will be working on. For now, I'm working on implementation of the video control framework for the video subsystems, and with this we will build more infrastructures so that the video framework can do more work on behalf of the drivers. Because for now, with the video API buttons currently, the drivers do most of the works, and there are some common works that we can offload to the video frameworks, and I think this is an important point to add
Okay.
to the video APIs. Yeah.
Right. And so there's a question from Xavier. I mean, I will put it on the screen and we can maybe address it in just a few minutes. But just because this is mentioning USB, one thing that I think, if I understand correctly, will also be coming in 4.1, that I think will make for me at least, like for really cool demos, if nothing else, is support for USB video camera device class, so that essentially like you can build webcams with Zephyr. So it should be pretty interesting. There's already a PR there, so I encourage people to check it out. But yeah, thanks Fibang. We're gonna, I mean, yeah, we're only a few minutes away, I guess, from the top of the hour. So let's try and keep this rolling. I want to bring Robert on stage to talk about all things networking. There's at least one thing that's being called out here. Sorry, here in the release notes, the addition of a new Prometheus library and code sample to help with exposing Prometheus metrics to a Prometheus environment and server. But I'm sure there's more. So yeah, Robert, like what are some of the highlights from your point of view around all things networking, Wi-Fi, etc.?
Yeah, so the list of the networking changes was pretty extensive as usual for this release, but there are a few areas that I think deserve especially to be highlighted. For example, there was a lot of activity in the Wi-Fi area. A few releases back, we have introduced Zephyr port for the W supplicant project for Wi-Fi networks authentication. Right. And now for this release, we are finally getting first native Wi-Fi drivers that are supporting it. So we have 2 drivers that can use the supplicants to authenticate. Moreover, the supplicant integration itself has been also improving during this release cycle. So we have now support for Wi-Fi Easy Connect or for additional security modes like enterprise. What's also interesting in this area that we now have a new Wi-Fi credentials library that can be used to store Wi-Fi credentials in the persistent storage, and then those credentials can be used when connecting with supplicants to connect to the network that's best fit from the provided list. Regarding samples, it should now also be easier to run Wi-Fi with certain networking samples, as we have introduced the Wi-Fi snippet, which should allow users to easily reconfigure particular networking samples to use Wi-Fi as the second layer, which could be pretty useful. So there are a lot of more in the Wi-Fi area, but there's no time to go over everything. So maybe we could jump to another topic, which was also pretty interesting in my opinion, which is the activity around the HTTP server.
Yes. Yeah.
So the HTTP server was introduced in the previous release, and we as contributors were hoping for getting feedback from users actually starting to use it and provide suggestions, and that's exactly what happened. We had some reports from developers trying to use it, but not only feedback with suggestions, we've actually received some contributions, very nice contributions towards the HTTP server. So we now have, for example, a new resource type, file system resource, which allows to fetch resource contents directly from file system instead of defining them in an array. What's also interesting is that the dynamic resource, which was introduced in the initial implementation of the server, has been refactored a lot. It not only now supports additional features like allows the application to access HTTP request headers or to specify the HTTP request headers for the response, but it also was simplified a bit so that users dealing with short requests and responses have a little easier life to implement their projects. So yeah, another honorable mention is the Prometheus metrics library, which you have covered in the release video. So maybe there's no point getting into a lot of details. We can just refer folks to check the video. But yeah, as for this library, we have a demo application which integrates the Prometheus library with the HTTP server. And I know there's also plans to improve integration of the Prometheus metrics with the actual metrics provided by Zephyr. For now, we're talking about the network stats. So this is already an ongoing work. Hopefully, we'll be able to have this in the next release.
Because there's lots of metrics that are already can be enabled in Zephyr, and in theory they should be it should be possible to automatically expose them as Prometheus metrics, right? So I guess that's
Yes.
your. Yep, cool.
So yeah, there's been a lot of more, but as I said, it's impossible to cover everything. So I think we can stop here.
Yeah, cool. So yeah, people watching, if you have questions around networking, feel free to ask so that we can address them. And with that, I think I'm going to bring everyone. A heads up that I'm going to bring everyone back on the screen so that we can maybe have a quick another quick look at the list, see whether there's anything that I have been missing. All right, lots of clicks to do. Hey, welcome back. Anas, you're on mute. I don't know if you wanted to say something. All right, so yeah, let me put my screen again too. One thing, I mean, I mentioned we have Gillet actually who joined us as well backstage. Stepper motors, I went over it quickly just before. Gillet, you join us mid show. If you want to tell us real quick what this is all about. One question that I also meant to ask you, assuming that you can answer it, is what's the actual application or applications that you're building with Stepper motors? Because I mean, like I mentioned in the blog post, this is of course like used in various industries, from medical to industrial, etc. But I would actually be personally curious to hear what's the application, and yeah, and then we can also talk about, especially a question to Mahesh and Dan as release managers. I'm sure you've spotted some interesting things that maybe are just like one random bullet point in the release notes, but that you may have some thoughts about. So yeah, Gillet, real quick, do you want to tell us a bit about Stepper motors?
Yeah, sure. Can you guys hear me right now?
Yep.
Or how's
Yep.
it? Yeah. So yeah, thanks for inviting me to the call. And so yeah, I work as embedded software engineer at SciS, and the application for Stepper motors is in the medical products at SciS. So I do not know how much I can actually disclose, but yeah, it goes into, let's say, microscopes at the end of the day. Yeah, and
Okay.
that's what the application is. And of course, when it comes to medical products, that has to be a certain level of precision, and that's why Stepper motors, because yeah, I mean, you can do the positioning pretty precisely with Stepper motors at the end of the day. And yeah, so this entire activity started with an RSC, I guess, sometime last year. And then we were able to bring API with a lot of help from the community, with with some functions for being able to configure the Stepper motor drivers, and drive the Stepper motors eventually. And so we've been able to like put two drivers in this release 4.0. Which is like one of them is like a really rudimentary, where you just have this GPI bitbank kind of driver, and the other one is this one with dynamic, where you have this sensorless stall detection and all. Yeah, so I'm looking forward to how it goes ahead from here onwards.
Yeah, that's cool. Well, so microscopes running Zephyr. That's cool. All right. Yeah, thanks for the update. Let me just like I mentioned, put everyone back on screen. Let's see, did I forget anyone? I didn't. Yeah, maybe starting with Dan, Mahesh. I know we only have a few minutes left, but as release managers, I mean, you've been pretty busy with maybe some of the boring work of just like going through the various processes, etc., to make sure that we get a good release out. But I hope this was also sort of rewarding in that you got to see some interesting developments. Like, was there anything in particular that caught your attention?
There's a lot of work, a lot of things going into Zephyr. And one of the things we captured in the release notes is the number of boards that were added in this release, and number of boards and shields. We added 60, is what the release note says, 60 new boards and shields. That's a lot.
Yeah,
so,
I think it's unprecedented. Like, we always get quite a lot, but that's that's a lot.
Yeah, so I mean, that itself tells us that we were quite busy in this release, and as release managers, we hope we could get as much as we could into this release. And Dan,
Yeah, cool.
anything from you?
I really like the secure storage from Tomi. Sorry, that was for me one of the big items to come in, and really appreciate the effort that it took to get in. So, thanks, Tomi.
Yeah, no, that was great work. And like I mentioned, this is I'm pretty sure this is work that I mean, it was more than just one release worth of work. Like it was started like Stepper Motors too, I guess, but it was more than a few months of efforts. Yeah. So anything else from folks on? Let me see. I don't think there's. Well, we have the question on USB host. Do any of you feel like they have a good answer to Xavier with regards to where we're at regarding a USB host as opposed to USB device stack? And I'm sure there's some RFCs and GitHub issues we could be pointing to. That's for sure. So I will do that. I will put, and I will show some links and on LinkedIn for Xavier.
It is being accelerated right now, that's for sure. There's a lot of things going on there. Yeah, it's still called experimental, but there's a lot of things going in and changes. So that's actually really good that it is picking up.
Yeah, I think that's a good point. I think for USB, all things USB, my impression is that we are pretty conservative in the way we call the stack. Like it's called experimental, but in practice, there's actually quite a lot. Oh, this one is actually really interesting. Tyler is asking, contribution-wise, like, are there any low-hanging fruits that we could recommend? So, short answer is that I think we have. I know that we have a label for issues and pull requests, which off the top of my head is good first issue. So you can look for that, but we might not be doing the best job at labeling and triaging those low-hanging fruits. So you can start there, but you can also join Discord. I think I probably have a link. There we go. Join us on Discord if you haven't already. There's you can just hop in whatever channel corresponds to your area of interest or expertise, and some people might be able to point you to issues that require some love, some help. That would be appreciated for sure. Any thoughts from others on low-hanging fruits?
For me, yeah, I think if you see anything while using Zephyr that you like, oh, this could be improved, or like, yeah, just you start using it, you see things that could be improved, then you just start. You can just start submitting pull requests this way.
Yeah, correct. Yeah, that could be just like you're going through a code sample. You don't find the README all that helpful. You just whatever instructions you feel were missing, you add them, submit a pull request, and that will be your first contribution. It doesn't have to be something that for which we already have a ticket, right? So yeah.
I was about to say the same thing. Is like documentation updates might be a good start. Like anything that you may find missing in our READMEs or in our documentation, that might be a good place to start. That might get you just familiar with the Zephyr process of submitting a PR and just.
Yep. So we are reaching the end of the hour. Anything else that you guys want to share or mention with regards to what's top of mind for you all for the next few months?
I do have something to mention quickly. I'll try to make it coming up in the next releases. So it's somewhat related to crypto adoption of PSA Crypto API, because another alternative so far has been TinyCrypt, which has been, it's about low footprint, but it hasn't been maintained for many years. And so Zephyr is finally getting rid of it. But unfortunately, the deprecation didn't quite make it into 4.0.
Yep, we almost got it.
Almost, but not quite. But it will happen for 4.1. So what this means is, well, in practice, there's still, I think, there have been some changes in for 4.0 that remove TinyCrypt as an option for certain subsystems, like as the underlying implementation. So this is not something that directly impacts the application, but yeah, a bit more indirectly. But so in 4.1, the rest will be merged, will be done. And according to the process, 2 releases later, so for 4.3 normally, TinyCrypt will be completely removed from the Zephyr code base. So just as a heads up, that's like there's also a mail that was sent to the Zephyr mailing list, so that people are aware that this is coming up.
But yeah, thanks for mentioning it. It's quite an important change. So yeah, thanks for calling it out. Yeah, with that, I think we're running out of time. We should have planned for more. I don't know. Tell us in the comments if you think we could have done it differently. Subscribe again to the YouTube channel if you haven't watched the demo video and the highlights of 4.0 if you want to learn even more. And with that, yeah, thanks everyone. I guess we will be back in a couple of weeks for another tech talk, in a couple months for another release. Thanks everyone. Bye.
Thanks, Benjamin. Bye.
Thank you, everyone.
Bye.
Thank you.